conservative force. Conservative forces are any force where the work done by that force on an object only depend on the initial and the final position of the object. In other words, the work done by a conservative force on a mass doesn't depend on the path taken by that mass. For instance, the gravitational force on a 5 kilogram mass is 49 Newton. If the mass moved downwards by an amount of 6 meters, the work done by the gravity will be 294 joules. Now let's start over. Say that the mass again moved down 6 meters, but then it moves up 6 meters. The work done by gravity for the first down trip was 294 joules. Then, for the upward strip, since the gravitational force in the opposite direction of the motion of the mass, the work done by gravity will be negative 294 joules. Then for the last strip downward, the work again is positive 294 joules. That means the total work done on mass from the gravity is still 294 joules. In other words, the work done by the gravitational force doesn't depend on the specific path taken by the mass. The work done on gravity depends only on the initial and the final position of the mass. In fact, you can allow the mass to take any path to the initial point to the final point, and the work done by gravity is still just gonna be positive 294 joules. Because the work done by gravity doesn't depend on the path taken, we call gravity a conservative force. The term conservative force comes from the fact that conservative force conserve mechanical energy and non-conservative force do not conserve mechanical energy. Example of non-conservative force is friction. Mechanical energy is kinetic energy plus potential energy. If I move a mass along a table from point A towards the point B, friction does certain amount of negative work on the mass, which creates thermal energy. If instead of going from A to B, I just make the mass move over and over and over, the work done by friction will become larger and larger and it will generate more thermal energy. Thus, the work done by friction depends on the path taken. Friction is not a conservative force. Similarly, air resistance is not a conservative force since the work done by air resistance depends on the specific path taken. It's useful to know you can define a potential energy for that force. That's why conservative force are like gravity and spring force have potential energy associated with them. Non-conservative force like friction do not have potential energy associated with them. Hope so it's clear. Thank you.